Okay, so in this video we're going to begin creating our super risk control, and we know that our super risk control is going to consist of an asset, and inside our asset will be our IK handle and our two risk control objects. Now, since those objects exist down inside the asset, we need some way of giving them parenting information, giving them transformation information that belongs to other parts of the rig that they'll be parented into. In order to do that, what we're going to do is we're going to set up some nodes that exist outside the asset, then fetch the transformations of those nodes down inside our asset, and use those fetch objects as parents of the various controls. So in this video we're going to set up those external nodes that consist of the parenting information we're interested in. We'll also create the fetch objects for grabbing that information, and then when we collapse those fetch objects into an asset, they'll be grabbing that information down into the asset. We'll also talk a little bit about editable nodes. Since now we have an asset, we can demonstrate making the IK handle an editable node, not making the IK handle the editable version of the IK handle an editable node, and the difference that we'll get in terms of one will work and the other will throw a permission error. So with that, I want to start off creating what will become the parent of our risk control that is parented in, if you will, to the arm, so that it inherits the arm's orientations, because if we look at our IK control, we already have that parent that we can reference the transformations from. We've got that L underscore arm underscore IK handle underscore initial position. That is going to be the parent if we reference his transforms and then parent our IK handle and our arm editable IK handle into those. Now you will notice that our IK handle has 0 transformations, no pre-transform, that's fine. Our editable has no pre-transform, which is exactly what we need to match the same space as the arm IK handle. It's got some garbage translations. That's from when we run our script. Obviously this guy gets set up with some transformations and then they get applied over to our IK handle. It doesn't matter if this ever has garbage transformations on. The only time we ever use it is when we run our script. When we run our script, we always update its translations to whatever we need in that instance of running the script. So I'm going to leave this with garbage transformations on because it really doesn't make any difference whatsoever. So I want to create an initial position, if you will, for what will become our risk control that is parented into the arm, and then from there I want to create another initial position for what will become our risk control that is in world space, or what I'm going to keep referring to as master control space, even though we know that currently we don't have a master control. Eventually this will exist in master control space. So to create the initial position and orientation for our risk control that's going to be parented to the arm, I want to inherit the orientation of our palm bone. Since really the risk control can be thought of as directly controlling that bone, I want in FK mode that orientation to match our palm bone when we're set to zeroed out parameters. So I'm going to branch off of L underscore palm into a new null, and I'm going to rename that null to L underscore 2 risk control underscore arm parent, and let's make sure we keep position when parenting, and I'm going to now reparent this into our lower arm. So that will keep us parented to the lower arm whilst maintaining the rotations needed to match us to the orientation, the initial orientation of the palm. Now you'll notice we have a very small value in X, we can zero that out. We have a very small value in Y, and we can zero that out. We need to translate down to the end of the arm based on the arm length, and we obviously don't want that to be a constant value because we know our arm's length can change. So I'm actually going to delete out that value and use a negative, and let's reference the L underscore lower arm, and I want to grab its length parameters so that we do indeed sit based on the length, and if our arm was to change length, our risk control is still going to sit at the end of the arm. Now with our master control space parent for the risk control, I want to basically have the rest orientation be our world space axes, so that if we blend over to that, we know that we're dealing with world space axes and rotations from those axes. However, I want the position of that control to still follow the end of the arm. Now, of course, when I say world space axes, that's world space axes currently. When we eventually have a master control in the next DVD and we get the master control set up, it will be whatever the orientation of our master control is. But for now, it's going to be the world space axes that we're working with. So I want to create a null that exists in world space that has world space orientation, but then reference the position of our newly created null so that we also sit at the end of the arm. So to do that, let's grab the arms to wrist control underscore arm parent, and let's start moving this to around about where our wrist control would be. I'm going to grab all of the bones in the hand, all of the hand, all the way up to the palm root, and just move this over to give ourselves some more space. I'm going to create a new unwired null. I'm going to rename this to L underscore to wrist control underscore master control parent. And this is going to be for our master control, and we're going to reference using the origin expression in our translations, reference currently in world space, and we're going to jump up and grab L underscore to wrist control underscore arm parent. And I want to grab the translation in X, so we're going to translate in X based on that other control object, or rather other null, and Y and Z as well. So in X, Y, and Z, we're going to grab the position of this guy. If this guy ever moves based on the arm changing position, our other null will stay in the same location, but its orientation, of course, is not being driven by the arm. So this is why I'm referring to the control object that will be a child of this guy being attached. It's attached into the arm. It inherits the orientation of the arm. The other control object is detached. It doesn't inherit any of the orientations. It merely currently inherits the position, and that's because we know that our wrist control will always be in the position of our wrist. That's not something we ever control with that control object. So now that we have that in place, we can go ahead and set up our fetch objects. I do want to grab nodes for our IK handle as well. Let's position these over here so that I'm dealing with the 3 nodes that will become our nodes that we send over to our arm, a super wrist control asset, and I'm going to rename this to 2IK or 2arm IK control, so that we know that we're sending to the arm IK control. Even name that to 2arm IK handle to match with the fact that this is IK handle as opposed to the IK control, just to match the naming. So we got those 3 nodes in place. We need to fetch those nodes. So I'm going to create a new fetch object. I'm going to follow my color schemes that I used back in the technical rigging series and give this guy a purple node color and capitals in terms of its name. So that's going to be fetch underscore, and I'm going to name this to fetch underscore IK underscore handle. And I want to go ahead and fetch that initial position. So I want to fetch that 2arm IK handle. So let's find our 2L underscore 2arm IK handle, making sure to export a relative path. So we're going to grab 2IK handle. We can see that we've got that. And I want to make sure in this case that indeed we use the parent transform of the fetched object, because I want to make sure that if this was parented into anything else and that object was to move, that I do indeed grab the entire transform and not simply his own local transforms. I also want to uncheck use parent transform of this object, and that's because currently our fetch exists in OBJ, and that's fine. In a second it's going to exist inside an asset. When it's inside an asset, if that asset was to get moved, it would by default inherit those transformations. I don't want to do that. That asset is going to be set up in such a way that we shouldn't be able to move it. I'm going to lock the transformation parameters. But for whatever reason, if it was to somehow get moved for whatever reason, I do not want the control objects to inherit those transformations. That's because if they did, we'd find that our rest positions, setting things back to 0, would not be the correct rest positions. Because obviously if we move that asset, 0 is now rest position offset by whatever that transformation of the asset is, and that's not what we want. So we're not going to be affected by the transformations of our asset. Our asset is merely acting as a container. So with that in place, we now have the arm IK handle fetched. We can grab the L underscore IK handle editable and the IK handle itself, and whilst keeping position we can reparent both of these to the fetch IK handle. You'll notice that this should leave both of these with whatever transformations they had before. So this guy has 0 transformations, no pre-transform, fantastic. And this guy has his garbage transformations and no pre-transform, so that's going to work out fantastically for us as well. Can turn off the visibility and selectability of that fetch. And now I'm going to go ahead and duplicate this twice over, once to grab our 2 wrist control arm parent and once to grab the 2 wrist control master control parent. So I'm going to Control C, Control V to duplicate. Let's rename this to fetch underscore wrist control underscore arm parent, and the fetch object in this case is going to be to the risk control arm parent, accept. If we bring up the visibility temporarily, we can see indeed we are there, and we know the arm parent has parenting. If we were to turn off use parent transform of fetch object, you'll see that we don't inherit the parent transforms. We need those parent transforms, thus we need to have use parent transform of fetched object checked. So there's our arm parent. I'm going to Control C, Control V, and create our one for our master control parent. And again, update this now to grab the master control parent. Turning on visibility, we can see indeed we are grabbing that guy correctly as well. So we've got these 5 nodes, the 3 fetches and our 2 IK handle nodes. I'm going to grab these and Shift C to collapse them into a subnet. I'm going to rename that subnet to super wrist control. And then I'm going to right click and create a digital asset from this subnet. So let's give this the name of super wrist control. And jump into our OTLs. I want to create an OTL from our HIP file into the OTLs folder and create a super wrist control.otl and accept. In the exact same way when we created our ARM FKIK controls, we could bundle all this into an asset with our Goblin. In this case, I'm taking the approach of just keeping everything separate in case for whatever reason I'd ever want to reuse these at a later date in a different character without having to install the character as a whole. So I'm going to accept that and accept. That's going to bring up the type properties. It's also going to throw an error because of our fetch objects, and that's fine because they're referencing things that are outside of our asset, and we know that that's the whole point of the fetch objects, is to reference things outside the asset. We're going to be promoting up those fetch parameters anyway, so this is not an issue at all. So let's make sure we've got our type properties. On the parameters tab, I'm not going to hide out our transform tab because this is really an internal asset, so it's only ever going to be used by us and it's only ever going to be used inside a larger asset. I need to see the transform parameters when I create an instance of this asset so that I can lock those parameters to stop anyone from moving the asset. And that's because you're going to see later on when we select the asset, we only want to be able to control that asset with the handles that we promote to the asset, and we don't want a user to come in, an animator to come in and grab the move tool, see that they can move the asset. That wouldn't make sense. So we're going to lock those parameters. Those parameters will never get promoted up to the final character asset level. We're simply going to work with promoting up handles to this asset so that we can work with the individual components inside it. So I'm going to leave those visible. I am going to create a new folder, and I'm going to rename that folder to something like super wrist control. And inside that folder, I want to promote up those 3 fetch parameters. So I'm going to turn off prefix, link name, and label. Jump inside our super wrist control and grab the 3 fetch objects from our different fetch objects. So I'm going to grab the fetch object path parameter, and this is for our IK handle. Promote that up. And I'm going to call this IK handle hook object. And let's just call this IK handle hook object. Go ahead and repeat this. So for our wrist control, promote up that fetch object. This will be our wrist arm parent hook object and wrist arm parent hook object, because indeed that was our arm parent wrist control. And we want to do the same for the master control. So promote that up, and we're going to have our wrist master parent hook object and wrist master parent hook object. So we can now go ahead and accept this. When we do, we can now see that we do have references to nodes, but those references have actually been set up incorrectly. They got promoted from before, and you notice we now have the incorrect path in terms of local to this particular node. Local to this particular node, we only need to jump up 1 level to grab each of these. So I'm going to delete out that first ... making sure that these do link to the correct nodes each time, just making sure that they're selecting the correct nodes. Indeed they are, so that is working fantastically. I do want to jump down inside the asset and make sure that the parameters themselves have been linked up using the channel SOP expression, and that's because I want to make sure that we're referencing the channel that we created as a string channel, and we want to grab an operator from that, as opposed to maybe having some other value in these. I wanted to make sure they were indeed promoted up correctly. So let's space these out just to create this a little bit more organized. Jump back up. I do also want to check on our ARM FKIK controls that we are now referencing the IK handle and editable IK handle inside our super risk control. Fantastic. So we know now that our super risk control is going to be used for both our left and right arm. That means I can rename these IK handles, removing out the L underscore, because we can now rename our asset to L underscore super risk control, but from inside there have everything with the same names without being forced to left or right. It makes much more sense to have L underscore super risk control / arm IK handle, or R underscore super risk control / arm IK handle, than having L underscore arm IK handle in both cases. So with that, let's jump up, let's lock our transform parameters. So I'm going to lock all of our transform parameters. So we want to make sure I lock the rotate order. There we go. This is just to make sure that that asset can't, for whatever reason, be moved. Now I do want to go ahead and demonstrate the editable node nature of our asset. So I'm going to basically right click, go down to type properties. If we're on the basic tab, we have the ability to specify editable nodes. Now to demonstrate this, I obviously need to promote up parameters from our IK handle. If you recall, our match IK to FK wants to work with moving the editable IK handle as well as the IK handle itself. So I need to promote up the translation parameters of our IK handle itself so that that doesn't cause a permission error, because obviously if they're down inside a locked asset, we can't change them. But then I also want to demonstrate what happens if we don't specify our editable IK handle as an editable node, and what happens if we do specify that. So let's go ahead and temporarily, because later on we're going to be promoting up these parameters by the way of promoting up handles to our asset. Right now I'm only temporarily doing this because I need these parameters on our asset to not get an error. So let's jump inside our super risk control, and actually we're inside our super risk control. Let's jump inside our arm IK handle, inside its transform tab, promote up its translates. I'll leave that there, it's just temporary, just so that we have something that will be edited. If we accept that, we can see we do indeed have some translation information. I can right click, save our operator, right click and match the current definition. This is now locked, which means that if we try and change nodes inside that locked asset, we are going to get an error, unless of course with our parameter references we use the .getReferencePalm. Now we're trying to change the IK handle editable. We're trying to set its world transform, and we haven't got it specified as an editable object right now, which means we are going to get a permission error. So if I come over to our ARM FKIK controls and I click on match IK to FK, we're going to get a permission error. You can see that we get failed to modify node or parameter because of a permission error. Possible causes include, and in this case it is this, locked asset. So we have a locked asset, which means we cannot match IK to FK because we're trying to change a node that's inside a locked asset. What we can do, I'm going to allow editing of contents, bring up the type properties for that asset. On the basic tab, I'm going to specify as an editable node at arm underscore IK handle underscore editable. This can be a space separated list of nodes, just the name of the node that exists inside our asset. This is now an editable node. Again, this is new for 9.5 in Houdini. It's a very powerful, very useful feature. So we can accept this. I want to make sure I save our operator type and match the current definition. So this is still locked. It was locked before and we got a permission error. It's locked now. If we click on match IK to FK, no permission error got thrown. If we take a look, you can see our translations right now have not been altered because of the fact that we don't have any changes we need to make. But if we were to come in and move our FK like so, and then we could go ahead and tell this to match IK to FK, you can see everything's matching. We're not getting any permission errors. So I'm going to undo that. Undo again, make sure that all of this is set to default values. Fantastic. I do also want to go ahead and turn off the visibility and selectability of those two nodes that we created for referencing for parenting information. So before we go, I want to remove that temporary parameter. Let's allow editing of contents, bring up our type properties. So let's remove that temporary parameter. I also want to go ahead and promote up the wireframe color parameter of our IK handle, because since this node will be used for left and right, and I want to change the wireframe color of those nodes for left and right, it makes sense to have that promoted. So I'm going to grab our ARM IK handle under the MISC tab, the wireframe color I'm going to promote up, move into our super risk control, and I'm going to give this the label of standard wireframe color, as opposed to detached wireframe color, standard wireframe color. So if we accept that now, and we'll see that we now have on our super risk control that wireframe color, which if we jump inside our risk control, that is controlling the wireframe color of our IK handle. So I'm going to save our operator type. In the next video, we'll continue working with this asset. We'll continue setting up our risk controls, blending between them, etc. But this is going to conclude this video. Thanks a lot, everyone.